Somewhere in the constellation Sextans, a beam of light just finished the longest journey any beam of light has ever completed to reach a human eye. It set off before Earth existed, before our sun existed, before almost anything existed. And in 2025, it landed on the mirrors of the James Webb Space Telescope. Astronomers call it Mom Z14, and it's forcing a lot of very smart people to ask an uncomfortable question. Did we get the early universe wrong? Let's start with the basics. Light is fast, about 186,000 miles per second, the speed limit of the universe. But the universe is so large that fast still isn't instant. When you look at something far away, you're not seeing it as it is. You're seeing it as it was, back when the light first left it. So the farther out astronomers look, the further back in time they're actually seeing. And right now, nothing lets us look further back than the James Webb Space Telescope. The universe itself is about 13.8 billion years old. For the first stretch of that timeline, a few 100 million years, there were no stars and no galaxies at all. Just a dark fog of hydrogen and helium. Scientists call this stretch the cosmic dark ages. Eventually, gravity pulled that gas together, the first stars switched on, and their radiation burned through the fog in a process called reionization. That moment is what astronomers refer to as cosmic dawn, and it's exactly what JWST was built to find. For a while, the record for most distant known galaxy belonged to Jade's GSZ140, a galaxy Webb spotted with a redshift of about 14.3, corresponding to roughly 290 million years after the Big Bang. Redshift, by the way, is basically the yardstick astronomers use for cosmic distance. As light crosses the stretching fabric of space, its wavelength gets stretched too, shifting toward red. The higher the redshift number, the further back in time you're looking. Then, in 2025, a team led by astronomer Rohan Naidu at MIT's Kavli Institute noticed something odd buried in existing Webb data. An object that showed up clearly in infrared light, but vanished almost completely at shorter wavelengths, the signature of light that has been stretched by an enormous distance. They pointed Webb's near-spec instrument directly at it, split the light into its component wavelengths, and confirmed a redshift of 14.44. They named it Mom Z14, short for Mirage or Miracle, the survey it came from, and it broke the record. This is light that left its source about 280 million years after the Big Bang, when the universe was roughly 2% of its current age. Picture the entire 13.8 billion year history of the universe squeezed into one calendar year, with the Big Bang landing on January 1st. On that scale, Mom Z14 existed on January 7th. Dinosaurs don't show up until Christmas Day. Modern humans arrive in the final minutes of New Year's Eve. And somehow, in the early 2020s, a species that didn't exist until the last 10 minutes of that year built a telescope that can see all the way back to January 7th. Here's where it gets strange. Mom Z14 is small. Astronomers estimate it's only a few hundred light-years across, compared to our Milky Way's roughly 100,000 light-year span. That's not a galaxy. By size, it's barely a smudge. And yet it's blazing remarkably luminous for something so young and so small. Brighter than standard models of early galaxy formation say it has any right to be. It's not alone either. The Mirage or Miracle survey suggests bright galaxies like this one are showing up in numbers roughly 100 times higher than pre-Webb models predicted. This isn't a one-off fluke, it's a pattern. Since Webb began operating in 2022, it has repeatedly found galaxies in the early universe that are too bright, too massive, or too chemically mature for their age. Spectral analysis of Mom Z14 even picked up signs of nitrogen, carbon, and oxygen-heavier elements that are usually the byproduct of generations of star formation, not something you'd expect from a galaxy only 280 million years removed from the Big Bang. Some researchers have pointed out that this chemical fingerprint resembles what we see in globular clusters, some of the oldest structures in the cosmos, objects we assumed took billions of years to form. None of this means our physics is broken. It means the standard model of galaxy formation, built carefully over decades, is missing an ingredient. Maybe gas collapsed into stars faster than we assumed. Maybe dark matter seeded structure earlier than the models allow. Maybe something else entirely. Scientists don't have the full answer yet, and this record will likely fall again soon. It's not a matter of if, but when. But Mom Z14 isn't the only thing about the early universe that's raising eyebrows. In 2025, a computer scientist at Kansas State University, Lior Shamir, ran an analysis on 263 galaxies photographed by Webb's Advanced Deep Extragalactic Survey. In a genuinely random universe, you'd expect roughly half of all spiral galaxies to rotate clockwise and half counterclockwise, purely by chance. Shamir's data showed something else. Close to 2/3 of the galaxies rotated the same way. That's a real statistical imbalance, and it's not something standard cosmology predicts. One possible mundane explanation is that our own galaxy's motion is subtly biasing which way distant galaxies appear to spin from our point of view, or that some of our distance measurements need recalibrating. But some physicists have floated a much stranger idea. What if the universe itself was born already spinning? That idea connects to something called black hole cosmology, a real, if speculative, line of theoretical physics. The concept goes like this. When enough matter collapses under gravity, it forms a black hole with an event horizon, a boundary past which nothing, not even light, escapes. What actually happens to matter after it crosses that boundary is still unknown. Some theorists, including physicist Nikodem Poplavsky, have proposed that instead of crushing down into an infinitely small point, that matter could instead rebound in what's sometimes called a big bounce, triggering an expansion that looks, from the inside, exactly like a Big Bang. In other words, every black hole might be the seed of a brand new universe, and our universe might be sitting inside one that formed inside some larger, older universe. If a black hole birthed our universe, and that black hole had a rotation axis, then galaxies inheriting a preferred spin direction wouldn't be as crazy as it sounds. It's a bold idea, and most cosmologists remain skeptical. Extraordinary claims need extraordinary evidence, and one statistical study isn't proof of anything. But it's exactly the kind of anomaly that keeps physicists up at night. Whatever the explanation turns out to be new physics, a hidden cosmic axis, or simply gaps in our early universe models, one thing is clear. Every time Webb looks a little further back, the universe looks a little stranger than the textbooks predicted. And somewhere out past Mom Z14, there's almost certainly something even older, even stranger, waiting to break the record all over again.